Okay.
Okay, so welcome to the weekly Sunday developers meeting on Skype 60. Um, we're talking today about several topics about the alpha version, about development in whole, and I will begin with a quick intro about what we are going to change on Discord. We heard you developers, for being able to have discussions on on a high quality level, um, without having messy timelines in messaging boards, for example. And our idea is now to go back to Discord, to remove the developers group from Signal. I mean, we are still in contact. I mean, sorry. But we think it makes much more sense to do all this stuff directly on Discord, where we already have those channels for particular workplaces, and we want to reconfigure them for developers only being able to post and discuss there, and all others of the community are only viewers only. Or how do you say viewing only?
Yeah.
Um,
They would still to talk in the community channels, but not specifically in the development channels.
yeah.
Though they could always raise a question in a community channel that we answer and
Bojan, I
direct them
just want to
to.
inform you you're recorded and on YouTube. Okay, anyway. um,
Okay, ready? 1, 2, 3, go. Now,
He
at
had
this point,
clothes on like 20 minutes ago, so I don't know what happened in
I'm
the
not
the
cutting that
in-between
out, I
time.
tell you. I'm not editing that.
It's a hot day.
It's a hot day in Florida, as you can see. So let's start. Christian, maybe we start with you.
Okay.
Let's from the big picture.
Yeah, from the big picture. What we did in the last week was I was writing on the dev guide again to give a much better view of the bigger picture and about some guidelines that we want to pursue while developing. I talked to Ido, to Nikola, and to Mike G about some stuff that might come in handy. Because Ido's here, I'm going to start with you. We discussed some things about ROS 2 and and I asked you about writing some text for the development guide so that you, me, and whoever wants to step in knows where we're heading with it, where the differences are, where the advantages are, and something that can guide us while deciding where to go. Nikola is going to write a small task about including archived material and showing it to the web GUI, so the web GUI can be tested, and he's going to write some text down about how he's going to develop that and discusses some issues or a way how to get it done. And Mike G is going to write something down how he developed his simple tracker and pointed out that we should give some credit to Paul Lamter, that which I agreed because they both did it together, and that his text should be the same. We won't include any code, but only how to develop things. So anybody can take it as, let's say, an example or whatever. And we are at the point that for the All Sky Cam, a description of how to think about what has to be done about the optics and the cameras is finished. There are some formulas in it to calculate the basic stuff, what resolution you need, what camera is involved in, and that's basically it what we have done within the last week.
So what you
And
already Sorry, may I interrupt?
Pardon?
So what you already can say is that we are now going for the setup, the QHY183c Pro camera with an adapter that you are still in development, plus the Meike 3.5 millimeter
Yes,
fisheye.
we introduced a new fisheye lens, the Meike MK minus 3.5. This is a good compromise between resolution, magnification, and field of view. This fit together. I used this fisheye lens with the Lumix DMC G3 a camera that I had on hand because it was quick and dirty, and could get a good guess about what field of view to gain and maybe some other issues to attend to. But this is a good test, and yeah, the QHY I tested with a different optics from ZWO, the TV lens that some of the old Sky projects are using for cloud coverage or something like that. And yeah, the image is nice. The chip is large enough for things, so it will be a good combi, yeah.
So can you give us an idea of the projection itself? How much field of view will we get?
From the calculations, it will be around 160 degrees. This is enough because the optics does an equi-solid angle projection, so you've got a distance distortion and a radial distortion. So the, let's say, up to 30 degrees below horizon, above horizon, the image will be very much distorted. And normally you've got maybe houses, trees, or something like that. So the horizon about 20 to 30 degrees will be covered already. So it is enough for field of view.
Mm-hmm.
The camera has 5,544 by 3,846 pixels. We are going to use a region of interest of it by 3,600 by 3,600 pixels.
Mm-hmm.
And this will cover the aperture of the fisheye lens in a very good way. So we do not lose anything.
Okay.
Because the aperture is 60 millimeters, we are in the desired range for what we want to collect. So the ISS, in a mathematical way, it will cover about 1 pixel, but since we do have atmosphere, it will be blurred out. So I would say on a normal day, the ISS will cover around 4 to 5 pixels because it's blurred out, and the signal to noise ratio gets reduced. But I think it will still be coverable by the simple tracker. Yes. So the combination looks very good. I'm very confident that it will work.
And it only, let's say, from the horizon, we kick away 10 degrees on the edge.
I would say
gives us
at least 20.
At least 20? But you said
Yes.
160 degrees, which is 10 on 10 on both sides.
Yes, this 160 degrees will be. It's an estimation because you can't calculate it. The formulas are modals
on the optic group.
And yes, and of course the circumstances in the atmosphere. The lower you get to the horizon, the more air you have. So refraction from that is high. The density is much higher. So you have got extinction of light, and this you have to take into account. And during the night, this is much worse because the ambient light is low. So I would say 20 degrees. Is up to 20 degrees is a good value that we can skip.
But
Yeah,
if you
we're not
want,
losing anything important, I don't think, because of how these are going to be installed. I mean, unless you're on the very tallest building in town, or you've got a very, very good view of the horizon, that most of us are going to be in towns where that lower 20 degrees to the horizon is going to be full of noise and nonsense. Trees, cars.
In common, this is true,
Right.
but what if you set up on the top of a building, or on top of a mountain, or in the desert, and then you don't have the horizon?
Then you're losing out.
But yes, I do get this, Christian, with us, with atmosphere and so forth. And I'm totally happy if we only use 10 degrees. Why you go to 20 degrees?
Yes.
I do not know.
No. I would say up to 20 degrees is a section where we may have much disturbance, so that we can't detect anything. It may be good, yes, but if it isn't, we are not sad about it.
Yeah. Okay, got it. So from that camera, can you guide us through the path of the material, the data that is collected on the sensor? How is it then further processed?
What we are up to now is that we take an image with an exposure time up to 1,000 of a second. This may give us up to 20 frames per second. We are going to store it on a pile. We are not sure if it will be a WebSocket, or, like Ido pointed out, we are going to use a ROS2 stuff, because we can save time with it. We discussed it last night or in the evening, and we are on it. But yes, we have to discuss it. What's the better way? This will be presented in the web GUI, in the dev GUI. In the dev guide we are writing. We are discussing it. The images come in as images, and then the web GUI and the tracker can take it and do whatever they should do with it. For the tracker, I'm not sure if resizing will do any good, but maybe segmentation and parallelization would be a key of using such large images like 3,600 by 3,600. This is where we stand at the moment.
Mm-hmm.
And Nikola is writing a routine that covers the archived material, and to do the same with the archived material.
Mm-hmm.
So next to machine learning, I will be working on archive service. Okay.
Yes.
And that means that I will be handling including the disk, and I will collect all the sensor data, because it also needs to be archived.
And maybe additionally, the ROS2 version, because it makes intensive use of Docker, may lead us to a version of the master control program to be Docker itself. So Docker can handle what we intended to do with a Python implementation of the master control program. This saves a lot of time.
Christian,
So-
are you hearing me? Christian,
So hold
Go
on.
ahead.
Bojan, can you turn on your microphone? You are very low on voice.
oh,
So, Christian, ROS2 doesn't require Docker, but it's just like a best practice to use Docker.
Yes, I agree with you. I think it is the best way, and if we use Docker to be the master control program, I think it's a wonderful idea.
Mm-hmm.
How does it replace master control program? I mean, Docker is just abstraction between kernel and applications.
This is what the master control program is about.
hey, Christian, are you hearing me?
Yeah.
Yeah.
Look, very important for software guys to explain what is difference between Zoom and
Okay. Yeah. I'm
know what
getting to that. This was a topic I wanted to do last, if we can.
Doesn't matter. But for example, Nikola doing the software side, and he didn't know what is different between zoom and
But I
focus.
talked, Nikola and me talked about that matter.
Yeah, this
because
is very important.
Yes.
I was
very
convinced that we
important.
have zoom, and it was actually a focus.
Very important for software guys to know what hardware guys doing.
Yeah. Okay, let's talk about that in the end, but now focus on the ROS stuff and how master control program may look like.
Okay.
And I think I give over to Ido, because he knows much more about it than I do.
Yeah, not that I'm an expert.
Makes a rhyme.
Yeah.
Much more expert than me.
So let's start with ROS2, right? So ROS2 is actually the second version of what is called a robotic operating system. It's not a really operating system. It's really, I would say, like a system of systems. So the idea in software, system of systems, is a system that allows you to build other systems, right? So it's both like a development framework and a runtime environment. That in ROS2 you really build what is called like packages. The packages communicate between each other through like a message bus. Okay, that message bus can be configured to be real-time, even hard real-time, if you want. You can synchronize it with the GPS, so you have time synchronicity on nanoseconds. And it's a very kind of developer friendly in a way. So once you build a package and you run it, the package either like publish messages or receive like messages like commands, and then it can interact with the sensor or device or whatever. For example, if I write a camera driver for ROS2, and by the way, 99% it already exists. We don't need to even write it. We just need to configure it. So what it does, it will connect through the USB to the camera. It will take the frames and push them on a topic on the message bus. Now, all the other packages that are interesting in images can actually subscribe to it and start receiving it. So if I want to do object detection, then I have a package that does object detection. Again, I can configure it to subscribe to the images topic, and it will start producing the detection objects on another topic, right?
And I do not have to copy the data around. And this is very important because it saves time. I do not have to copy the data around.
Yeah.
But same with regular message brokers, right?
Yeah. The difference here, these message brokers, of ROS2, it's actually using a protocol named DDS. Okay. I'll give you a bit of history. DDS exists like for a very long time. It's UDP based. It's being used in the like homeland security, defense systems. The rover on Mars uses it. F-16s, F-35 are using it, right? So that protocol, has a lot of like production experience, and it has all the publish subscribe kind of notions, that a lot of message queuers don't have, right? Again, it doesn't work with the storage. It's really all in memory, but things you can do for it. For example, in a command and control systems, advanced one, usually you have a record and replay kind of package. So the way it works, if you want to record anything, you go to the recorder and you just tell it which topics you want to record. And the recorder is responsible how to like store them in a database, file system, whatever it is. No one cares. And there are two types of recorders. There is a transient recorder that will store stuff in memory, right? So for example, the last 20 seconds of video streams. So when you do when you have a detection, you can actually ask, hey, give me the last 20 seconds of video, start streaming it to me.
Sweet.
So you have like the pre-detection kind of video, right? Yeah, so that's and then there is like the real kind of recorder that actually put it into disk. It has playback capabilities, so you can always subscribe to give me all the images between some time span, right? And it will start sending you those specifically. The way you subscribe to stuff, you can subscribe in a different way. You can subscribe in a lossy way, right? Again, because it's UDP, there is no guarantees on anything that you will receive. So if you are displaying something to the user, most of the time you don't need reliability, you just want the latest, right? So just subscribe to whatever and you start receiving. If you're speaking about a recorder usually will want the reliability, right? So it will subscribe to a reliable stream of all the images. And once you have a reliable subscription, the way RAW-Store will work underneath, it will actually configure DDS to ensure the images are arriving reliable to the recorder, right? So it knows how to optimize all the publish subscribe between all the components, which is really, really nice. Like I wish I had it like 15 years ago.
I have one question.
Yeah.
Copy the files, video files or picture.
Yeah.
How can, for example, distort the image so you can observe?
So what do you mean by storing the image to observe?
No, for example, I do have an image. I capture
Yes.
the image and
Yeah.
I copy and send to you. For example, for
You mean
examine.
outside our station.
Yes,
Oh,
outside.
yeah.
Out.
Okay. So another thing that I thought, when I started doing some high level architecture diagram, I was like, it's really nice when there is a detection in the system. If the system actually, if someone configure like a YouTube account, right? So the system can automatically start like a live stream and start sending all the images directly to YouTube. So you actually see the detection live, right? Extracting out, you can create a package that will say, hey, give me this time span or whatever window you want. Give me that as a video file or a group of images, and I can get that download. It's not that hard. And then you copy it through email, whatever. I mean, zip file, that doesn't really matter.
Right now I'm working mostly with a radio, trying to figure out what's going on about 1.6 gigahertz, if anything going on.
Yeah,
and
here. Actually, it's crashed.
Yeah, and it is very difficult to figure out what's going on. It is very. Most the stuff I scary is for me scary to pick up something than, for example, electronics. Doing not really receiving. Yeah. So this is it's kind of difficult.
Yeah, like around SDR, right? Again, think about a package that will use a USB, right, to connect to the SDR unit, right, and then to the antenna.
Yeah.
And then there are two things, right? And there is kind of the package itself that will listen and probably push or publish everything that it receives through the SDR. And then you'll have like an analyzer that will actually look for anomalies. And once an anomaly is there, right, because I have like 10 seconds, 20 seconds of history, I can say, okay, here is an interesting SDR event, right? And I will mark this time slices, those will be stored in disk, right?
Yeah.
So, what's important in ROS2 is really to understand what are the topics that we want and what are the commands and events that we want each package to kind of either publish or subscribe, right? Another example is like I start with the camera, 3000 by 3000, whatever. 2 years down the line, we decide like, hey, there is a better camera, it's cheaper. We do like an upgrade, right? So it's, let's say, 5,000 by 5,000 or 6,000 by 6,000, whatever. And Christian, I know, okay, just the idea. You can create settings on each package and then change them in runtime. So you can change the resolution of what you are capturing in runtime for the camera, right? You can change what you want to record on the SDR. So all of those are like settings of packages that you expose through, and you can change them through commands to the camera driver, to the package, the ROS2 package. Okay. Another thing, maybe I'll try to see if I can run it here real quick and share it. Just 1 second. So ROS2 come with a tool called RQT. And RQT, just a second.
RQT, real quick term?
Yeah. So, do you guys see my screen?
Coming. Yep.
Yeah, okay.
Yeah.
So this is RQT, right? So you see here like the different topics like images, and you see like the height, where the encoding was used, and of course the byte array of the data. It will show you what's the hertz of each topic that it's running, what's the bandwidth of it, if you want. You can debug it here. If it's an image, I can actually double click it. I mean, I don't have any packages running right now. I actually tried to do something and I crashed it, but I can actually see in real time the images that are being published by cameras. Okay, there is different plugins from like actions, configuration, different logging, different services, visualization even. So I can create a plot and on Signal that will actually show all the kind of the packages of ROS2 and how they communicate on which topic with each other. So it gives you like a nice kind of system diagram of what's going on. This tool is being used a lot also to do like simulation. So when you build robots, that do like autonomous navigation, like iRobot to clean your house, for example, or whatever you see those small robots on YouTube, right? That can show you how the robot, virtually move in space. You can create like a fake stream for it, for detection, so it will change its direction of moving, and all of that. There is a lot of open source kind of packages in ROS2.
May I ask? Sorry, one question that fits there. ROS2 as a real-time system. Can you even bring data to the front end in real time?
So I was looking at libraries for JavaScript, which is where the front end will be written, and there is not a lot of support for ROS2. There is no client libraries for JavaScript that are up to date and with a lot of downloads.
Yes, so there are two ways to do that, right? The one way of doing that is actually you build, let's say, a Node.js backend for the user interface, right? And that backend is subscribing to all of the ROS2 topics that are interesting for the UI, right?
But Node.js is in JavaScript. It is runtime for JavaScript, and ROS2 support is not that great in JavaScript world.
That was part of my conundrum.
I can run ROS2 inside Node.js.
What library are you using?
I'll find it. It shouldn't be a problem. And if that's a problem, you can run the DDS directly and get it. Okay, even if that's not going to work, you can still create a ROS2 package and just expose, a web stream or whatever.
That was part of my conundrum with Django. Why go with Django if we're only using it for a couple of Python libraries when it looks like Node would probably be better for everything?
I'm sorry?
That was part of my conundrum with Node versus Django. The more and more we talk, it just seems like the more Node.js would be the better option than using Django. If we're only using Django for a couple of Python libraries, then maybe we can find alternatives to those Python libraries or put those Python libraries in a separate container and just use the results from those libraries in Node.js. So anyway.
Yeah, I mean, this is really up to you. Like the whole idea of ROS2 is ROS2 is not like Python only. You can write packages in C, C++, C#, Rust, whatever. And that's the beauty of it. Like it doesn't force you to use a certain programming language, right? Yeah. Sorry, I had something in my mind to say about that. I just like slipped my head. So yeah, if we make a choice to use ROS2 and you guys have a question how we subscribe and publish through like the Django or Node.js, I can look actually specifically around that and find a solution. Shouldn't be of a problem, okay? The mantra of ROS2, and that's what's important, is don't do it twice, right? So if there is already existing open source and you need like a fix to it or something, either fork it and extend it, or submit a pull request to that open source project, right? It's all about creating robot parts and like smart components in the end of the day, right? And yeah, now ROS2 can also give you what is called request reply mechanism to packages, like it's called like services. So you can request a specific service. Hey, give me, let's say from GPS, give me the location right now, and you will get that location within a guaranteed time window, right? Again, depends how much hard real time you want to be, but you can actually do that. Right.
So that means that ROS2 has some like ways to talk with some GPS modules, or there is some code that will glue ROS2 and this specific model of GPS.
So there are some implementation of GPS. Honestly, I haven't looked specifically about how to configure the GPS canal because what's important in GPS, from real-time perspective, is the accuracy of time, because that will allow you to do synchronization, and that's important for data fusion, right? So just to wrap the head, right? If you have 4 cameras that are reading frames in different times, and you try to do detection or fusion, actually, if you don't know the time ordering of those frames, you might get the vector of where the object is moving wrong. Right?
Yeah, for example, real-time photogrammetry, it requires all cameras to be extremely synced.
Yes, exactly. So, you can achieve the hard real-time, right? I'm not sure, okay, and this is where I still have the questions around the hard time, specifically if those are, additional libraries that are required, let's say, by the ePromisa implementation of DTS or the Connext by RTI, which are like the top 2, I would say. But these companies are big into open source, and they provide the production support, with their production kind of packages, right? So that's what will cost money, but again, we don't need that advanced hard time stuff and what they have. The open source should be more than enough. Now, ePromisa's implementation is actually the default in the latest ROS2. So again, ROS2 uses it has like a message bus kind of abstraction, and the default message bus for ROS2, the newer version, is I promisa fast DDS. Okay? Does that make sense?
Yes. I can add to that all the stuff around the cameras, the GPS, etc. This is already done in real time, including the timing by the INDI protocol. The INDI service taking care of that already, and this fits into the ROS concept in a very, very nice way. So I think that if we're using the INDI server with all its capabilities and talking and as included in a Docker container, and then using ROS2 as a messaging system, as an event handler for, let's say, the master control program, the event management, and the archive management. Then we stay all in the real-time segment, and we can get rid of all the message queuing and intercommunication that we would had to write as programs ourselves. So I think the ROS2 with the Docker container is the solution we are looking for.
Yeah. So let me
from the big picture.
Yeah, so let me get to the Docker, right? The Docker is all about like the deployment kind of thing, right? So the way ROS2 works, you create a workspace and then you clone under that workspace, the packages that you want to use, right? Similar if you import packages in Python, in the ROS2 environment, you are cloning those repositories of the implementation of like a camera driver, GPS, whatever. And then you create, like a workspace file that will tell ROS to load all of these packages once you start ROS2, right? Once you start the workspace. Now, when this is for development purposes. When you want, to have a deployment unit, you actually can use the ROS2 kind of Docker runtime and just give it a configuration file, which packages you want it to run. So we can create specific runtime kind of images, right, that are designed for like the PTZ camera, the fisheye, and to be more specific, to the compute edges that we have, like the nanos and the pies and stuff, right? So each one will have its own kind of single command in a way that will do like Docker run, an image, and that's it. You don't need to do anything more than that, right?
This was already in plan. We already decided to use Docker.
No, in combination with ROS2, that ROS2 is going to...
It doesn't matter. Is it we package our own code or we package the ROS2 inside of Docker?
Cool. Last I heard about Docker, I heard that there was some tries and there was a lot of confusion. So I'm happy to hear that, honestly.
So may I go into this Nikola and Ido? Nikola is preparing... Christian, please correct me if I'm wrong. Nikola is preparing a WebSocket so that Rebecca can pick that material, that data up and represent in the front end.
Yeah, for the moment we are going for a WebSocket. This can be replaced at any time because it doesn't matter where it's written to. So if we then go, let's say, for a more ROS2 style thing, then it is like this. We do not have to, if we choose a WebSocket now, we do not have to go for it, let's say, next week. We can change that very easily.
Yeah, of course, but my question
so I would say, let's talk about it as some kind of pile or stack. And whatever that nature is, doesn't have to be specified at the moment.
Okay.
Only that we've got a pile, we put something on, and something is fetching from there.
Okay, get it. But my point is more in detail. Ido, when you say we would not need a WebSocket because ROS with its layer and messaging system is already.
No, It's not about we wouldn't need, right? And again, it depends the perspective you want to take, right? If it's a closed system, right, there is a way to listen on UDP from JavaScript. So there will be a way to subscribe directly to ROS2 events. If that package doesn't exist, honestly, shouldn't be hard to implement it. I don't think so. But you know, if you move faster with a WebSocket, use a WebSocket. It's fine. It doesn't tell you don't use it, right? It just like for the what I call the robot parts, you want that message bus communication, right? You want that capability that now I have a new component or a new package that I want to create. I don't need to change anything in my system to start listening to events and start doing something, right? It will have some impact on the real time of things, right? Depends on how you subscribe. For example, if I create now a package that needs a history of 100 seconds, right? You're going to create load on the system because now the guarantees of 100-second deliveries is going to be quite a lot, right? And you need to know how to handle your memory on that specific package, because that package will hold that memory for you. That's what's beautiful about it. It's abstracted from you, but when it's subscribed, it holds in memory all the time the last, let's say, 100 frames. And every time you receive a new frame, it will give you another 100 frames, like in a queue that you're processing.
So that's on package level. Each package keeps what he needs.
Pretty much, yeah. But there will be changes in the communication. The ROS2 is smart enough to understand all the publish subscribe that are happening in a system, and it knows how to create those multicast channels, so that it's not overwhelming. So it's really good optimized. But if you need to even optimize that, you can actually like tweak the multicast for specific topic. You can isolate it even if you have two robots running on the same network. I think you can run over about like 200 or so. I can't remember. I need probably to look it up. But it's very advanced, the patterns that they have.
Okay, my question to all three of you, Ido, Nikola, Rebecca, is would it make sense to skip the WebSocket and to go for the ROS2 communication part?
Well, we already had in mind to use some kind of message queuing. So is it ROS with hardcore real-time, or is it NATS.io with slightly less real-time but still faster than 60 frames per second? I don't know. Yeah, it makes sense.
NATS.io is actually a very good choice. There are two modes to NATS.io. It's super light. It's running in memory. And if you like the MQTT of things, then it supports MQTT 3.3.
Yeah, and it also has this mechanism to deliver a message at least one time for certain. So you can guarantee for core systems that they will receive all data for sure. And you can also there is on top of.
I'll explain.
Okay.
So the engine or the core of NATS.io is actually in memory, and the guaranteed delivery is at most once. Very similar to UDP. Okay? However, you can configure NATS streaming, which is the newer version of how they did it. The first version was pretty bad. The newer version is much better. I actually saw a demo about a month ago. But that will require for delivery guarantees of at least once and exactly once. You will have to have storage, like persistency of messages. So that can be either a file system or a database.
8 gigs of RAM.
No, it won't be only on RAM. Only on RAM it will not give you the at least once delivery guarantee. Not from what I know about NATS.io.
With Jetstream?
With Jetstream. Oh, you're using the in-memory store, you mean?
Yeah, there is a layer on top of base
Okay.
Nets.io.
Yeah, I know. Yeah, so streaming requires a store plugin. You can create an in-memory store plugin that will do that. Yeah. Yeah. But again, you already have all that stuff in ROS2 and DDS. So
in basic setup, just when you install it, you get it already. In ROS.
Yeah.
Uh-huh.
Yeah. Yeah.
Are you sure you want to start over 30 days, 60 days out? There's been a lot of work put into it.
I don't think they've actually started on the intercommunication just yet, so now's the time to make that choice.
Yeah.
Mm-hmm.
That's why we brought up this topic.
Yeah.
Mm-hmm. Are you saying, though, that ROS2 then has everything that Nats.io has plus more?
Oh, yeah. Yes. Everything from development experience, much better. The debugging capabilities of ROS2 are exceeding what you can do with Nats.io. Nats.io, I would say it's light enough, it's strong enough. I'm a big fan of it. I used it before. I see it. The newer version, or the demo that I saw actually, you can do a lot of kind of routing. So those are scenarios more like for enterprise systems. For example, I want to do like A/B testing of a new feature, right? So I can actually tell Nats.io, take 10% of this stream and now actually take it out of that stream, put it in another stream for my new feature to be tested like in parallel. So you can do like A/B testing and stuff like that. But it's not something that you cannot do again with the ROS2 capabilities, because you can always create the other features, subscribe to the same events, and produce another stream, right? And you can configure that also. So it's a different way of doing that, but you can. It's how the operational side will work, right? The operational side of Nats2, it's more designed towards like these enterprise solutions. Okay. It has the replication. What it's called like a super cluster. So you can create on a data center a super cluster.
Yeah, because it relates with our architecture that will have another software that will be outside of the station and that will back up the internal SSD so we can free some space. So this is where we saw like it fits now really nice.
But again, if you have connectivity, then you can use also UDP.
WebSockets, everything.
I actually also ROS2 a demo, and I actually tweaked it to do videos later. But I saw a publisher from Germany, subscriber in US real time. Okay, with reliability on UDP over the internet. It was pretty cool. Okay. Again, the open source for that is probably doesn't exist, but again, those are advanced stuff that I probably don't think we will need. And if we do, we can create our own solutions. Doesn't necessarily need to be ROS2. You can still use Nats.io and do that if you want to. Okay.
Okay. So we stay. Nikola, what you say now?
I think that we don't need that much real time for station because we don't produce data as that often. So regular milliseconds can be fine for syncing and data merging, in my opinion. No need to, for example, have nanosecond intervals of precision with GPS and ROS2. because
So just a second. Real time means that you know how the system is behaving in a deterministic way. It doesn't mean it's a nanosecond or millisecond. Okay.
Real time means that a process is finished to a predetermined at a predetermined time. Let's say that, for example. Yes.
Yeah.
So
for example,
determined, to be determined. This is real time about.
Yeah. So if you have let's say a camera that gives you a real time of, let's say, 60 hertz images, right? You're guaranteed, right, that you will receive those images in that window.
Okay.
And again, real time also means what do I do in the case of a failure, right? So if there is a failure, which means I didn't receive the image in that given time, then you're not going to get that image at all. Okay, you're going to lose it. Now that's very important, okay, because of, again, determinism, but it's also from like a mission critical kind of safety procedure. I'll give an example, right? If you're in an autonomous car, right, and you're clicking the brake, and the brake didn't work within 100 milliseconds or whatever the time is, right? That's a hard failure, right? Like there is a big problem there, okay? You cannot receive the event of a brake 2 minutes after, or 2 seconds after. So you're guaranteed to receive it within that 100 milliseconds or not receiving it at all, okay?
Mm-hmm.
So basically, if you don't receive the braking signal within that 100 milliseconds, braking is shut off.
Yes.
Completely and never turned on again. Yeah.
Yeah. It's again, but this is not mission critical system. So
hardcore stuff.
I wouldn't say hardcore. It's different. Maybe it's good to speak about real time. There are two kind of ways of doing real time. There is the event-driven way, which is what ROS2 is doing, and then there is the time-sharing way. That it's different. The idea of a time-sharing, think about it, that you have like a runtime that runs, and think about it like modules, and it gives modules a time window to run. For example, 20 milliseconds, right? So now you can load as many modules as you want, but each one is going to run for 20 milliseconds, so you're going to create a frequency around each one. Usually the way they will work, each module will get a slice of memory to work with, to read and write from, right? And to communicate with the sensor. So it will, in that 20 milliseconds, what it needs to do, it's read what it needs to do from the memory, communicate if there is anything new with the sensor, or like execute commands or receiving something, and then put back the results to the memory. If it sees that it's can do another cycle and it has time on the 20 milliseconds, it will do that again. If not, it will go back and release the processing to another module to run. So it's really working on like a shared memory. And then you have a process that will take, again, like a module that will take what changed in the memory since the last frame and just dump it into the network, right? Again, different way of doing that. I find that the event-driven way, it's actually easier to work with. But you can do both. It doesn't hurt. And you can create very a nice thing if you know like functional programming, then you can create the functional of the system. You describe it as like a one big function, a composite function that will run in a deterministic way. Mm-hmm. So it's kind of beautiful if you think about it.
Mm-hmm. So from your perspective, totally understand the values of ROS and ROS2 for our system.
Yeah.
Would you consider it to be necessary for the front end as well? Because that question was not quite answered.
Yeah, not really.
Okay.
I am, I do question if we really want the Django or Node.js or whatever, right? But for different reasons, right? The Django is really used for, it's like a Python web framework that has tons of plugins. I kind of at this point look at it very similar to like a WordPress kind of world, right? For our system, I would lean towards more like like the Next.js.
Oh, actually, my software
advanced.
that I made, it's already in Next.js with Node and Neo4j and GraphQL.
Yes. So Next.js is a good foundation. It's actually on top of Node.js, gives you like more capabilities. React gives you the real-time kind of aspect, on the UI. So think about it as it gives you kind of 60 frames per second that it knows how to do updates, right? So you don't really interact with the HTTP DOM. So when you want to display something that has a lot of changes per second, React probably will be better, right? React, or the kind of the approach React took for development is actually better. You get better performance. Okay. But again, everything is fine. What I do want, yeah. Go
I
ahead.
think then we should go with Node.js and Next.js, like you were saying, and whatever Python that we're using, we'll just, those libraries, we'll just put them in containers and just get the information from them and display them in the Node site. I think that will be the better option.
Okay.
Yeah.
So I think what's important when you discuss like technology selection is really first thing what do you want Sky 360 to be? How do you want people that are going to use it to think about Sky 360, right? Because there is a certain emotion, certain thoughts when people correlate, let's say, with Node.js, with Docker, with ROS2, with the Django, with GraphQL you mentioned, right? There is a lot of opinion, a lot of that is kind of stuff. So you need to think about what are the values that we want to communicate and which technologies fit those values, right? We speak about accuracy, we speak about real time, we speak about that, ROS2 answer that, right? React will answer that on the UI, right? We want to be developer friendly, Docker speaks about that, right? Like easy to deploy, right? I've been an architect for like over 20 years of different systems, everything from border protection to financial systems to e-commerce to whatever. I never saw once one architecture that wins. What I saw win every time is a protocol, and I think that's why deciding on ROS2 is important, and understanding the commands and events, like the event driven of the system, because now you make a system that is very elastic. If a new ROS will come out or something better than the ROS2 will come out, right? You still know your protocol of how everything is working, so moving to that will be easier, right? Which I doubt. I think ROS2 is kind of on the right track, and I think it's going to stay for a very long time. But we're starting to see that architecture actually needs evolution very similar to how we write code, right? So architecture needs to change. This is where software and hardware kind of breaks, because in hardware the architecture doesn't change. You always have like a power bus, you always have like a data bus, and you connect everything together and it works, right? With software, you can imagine and you can work in very different ways. Right? You're muted.
You're
Christian.
muted.
Sorry. FPGAs are a way to achieve that with hardware, and there are solutions with writing Python code that can directly change the hardware in not yet real time, but is offered around Christmas. It's said to be real time. So yes, this is going in the same direction, and I'm clearly with you. Maybe thinking about how the web GUI should interact with the provided data stream. I don't think that we need real time in the web GUI. The web GUI is just a thing that someone who's not on the level of development can have a view what's going around at the moment with the station. This does not have to be real time. If we've got a delay for, let's say, some seconds in the video stream, it doesn't matter, because the hardware, the part that is on a sub level already caught the event. So you do not have a huge buffer that you push and now you're recording an event. We are not that real-time critical on that side, but and we're not real-time critical on the optical side where we gather the images, because this depends on how fast is the CMOS chip, how fast it can read out, how fast can this image be put somewhere. And I think because our exposure times are, let's say, between 1,000 of a second to up to, let's say, 1 second, in worst case, this defines how real-time our system really is. So I'm good with using ROS2 as maybe the container of providing the data. And if we have to write some kind of listening to device to get the data into the web GUI, okay, so we're going to do that.
Yeah. So I'm just looking. There is something called ROS Bridge Suite. That's a 7 implementation of a ROS Bridge v2 protocol, and it provides a JSON interface to ROS. Right. So that's like will be the way. I think, again, very rough estimate, but yeah, probably that will be a way for our backend, the UI backend, to communicate with ROS in and out. So that can be done.
Okay, I have another question. You mentioned the master control program at the very beginning, and you said actually the ROS2 is already a master control program. But I think we need a little bit more around that. So ROS2 is then, let's say, the core of the master control program with additional functionalities of management of events, for example, or archive management. Is that the idea?
So ROS2 will give you the runtime if you want anything management, for example. What's the serial number of the unit, right? How the unit is going to behave in case of an event detection, right? And all of that. So that's just another package that manages, right? And tell the other component what to do in a way, right?
Mm-hmm. Yeah.
So it's just another package on top.
So the actual part or the actual program that master control program is just taking all the links, putting them together, and say, okay, I call that, or I call that. So this is a very simple task, and it gets that simple because of the use of ROS2 systems.
Yeah, but it still has some logic, of course.
Yes, of course. Yeah, it has to decide what data we want to bind together.
Mm.
here,
And
so-
in case this data isn't there, what to do then? And
Okay.
to call, let's say, the event handler or the archive management. This is what the purpose of the master control program is. And using the constraints to the Docker containers that is provided by ROS2, I think from what I heard now and what I read earlier, it's the fastest possible way, and it makes sure that we don't lose anything.
And the same is true for the archive management that you mentioned before, because there's also
Yes.
something data that has to be shuffled from left to right.
Yes. And as a backup unit, we would use Neo4j and to put everything on the storage.
You mentioned Neo4j, the structure, the data structure itself has to be defined.
Neo4j is just a graph database.
Yeah, but the structure itself has to be the protocol therefore has to be defined.
The data format.
Yeah.
That has to be defined.
Yeah. So my question is, that belongs, for me, it belongs somehow together. Who is working on that part right now?
With archiving.
No,
because I have one software that can still evolve. It's not really specialized yet into anything, but it's using Neo4j and GraphQL, like I mentioned. And I chose GraphQL because one of the ways how you can interact with the Neo database is using graph query language instead of Cypher. But both are on the table. From my code, I'm using Cypher to interact with Neo4j, but other applications will kind of get that database abstracted away by this GraphQL API.
Yeah. And we can put that database and everything inside the Docker image with everything for the...
It's already in Docker, yeah.
Yeah. So the entire thing runs as one unit, which is super nice. So I found the ROS2 client for JavaScript.
Yeah, I did look at this one, and it has like 1,000 downloads on NPM. And when I work with NPM, if something has under 10K of downloads weekly, I just don't consider it even.
No, that's fine. That's fine. You know about that way more than me. But robotwebtools.org has a lot of information about different libraries.
Yeah, paste in Discord somewhere.
I'll send all of that. But you see, there is visualization and a lot of like insane stuff that they do. Rosberg, another one. 78 minutes. So they're in bunch. Now, around UI, right? If we go to Next.js, then I'll highly recommend, right, to look at what we are building. Again, our UI, I'll start from our UI is complex. It's not an easy trial to build. Particularly when you speak about the mapping and the object and where everything is, and that's we need to use some advanced visualization. So either we isolate it in something like 3D.js. I don't know if you guys looked at that.
I did work with that. I created a tool to generate a training data set for some application, and I was using the ShapeNet to source the 3D models and to picture them from multiple sides.
Cool, and then if you use that, it probably will be better to go, again, as a React component, it will just perform better and you will not have the issues. Like 3D.js inside React.
And now that you mentioned, I actually think that 3D visualization is much better than multiple layers of stuff. Because you have entire volumetric control, and later on when we have multiple stations, maybe we can pinpoint somewhere in 3D space instead of 2D space. and it will be much useful for user when looking at it.
Yeah, and then for the style sheeting of aspect, I'll recommend like Tailwind CSS. Again, it's easier to manage, better performance, and again, this is just by looking of how the UI is going to look like, and it's not trivial to build all of these components, and we need to think about it as a component-based thing. That's why React or similar that are I forgot.
Any single page framework like Angular or Vue.js, they can also work. They are all component-based frameworks for UIs.
Yeah, personally, I'm not a big fan of Angular, but sure, yeah. I think you get my point.
I get the general idea.
Yeah. There was one, I actually watched it. There is one that is becoming super popular. It's performing better than React and much lighter. And you write components very similar to it. I need to look up what it was.
I do kind of think this is for future releases though, because right now we're focusing on getting the camera view, are we not? And the mask. That's the first release. Yep. Camera view and mask, and then.
Oh, you want to show the camera in the
UI, yeah, but still you can use React. I already showed demo where you can update the DOM with a new image, like new frame from old SkyCam in so frequently. Yeah, it's
So it probably will be better if you have a backend component that will listen to the images, create a video stream, and then you listen to the video stream, which is lossy, right? Because you don't need the high resolution of it. That probably will be better.
Yeah.
Otherwise, you're killing the browser on the client side.
Or maybe just convert it to JPEG or something and stream the series of images.
Yeah, you don't want to send 3,000 by 3,000 frames, to the client all the time. That's heavy.
Yeah, but we need
considering that there isn't any display using 3,600 by 3,600 pixels at the moment.
Guys, but you all know that we need to see the 1:1 native resolution on any kind of sensor. So yes, when you see the fisheye view in total, then you might have 800 in vertical and horizontal. But when you zoom in, you want to go down to the native resolution. And that's why we have in some way to provide the full resolution, maybe cropped, but...
Yeah. So that once you have a detection event and you record it, right? Again, it will restore the high definition full frames, in the recorder, and you will be able to receive that if you want to.
It is just a matter of different component which will be specialized to display full resolution stuff.
Yeah, but think about it. If you want to provide access to the unit that is remote, right? You want the video stream to be more adaptive based on the quality of the connection that you have, right? So think about it. And again, I might speaking too advanced stuff 5 years from now, right?
May I interrupt in here? I think it does not make sense that you see from your station and your front end what on another station is going on. I think it only makes sense that your UI is with another view allowing you to get the big picture, but not particular one station.
I was thinking about more. It will nice for me as like an owner of a unit, right? To be able to see videos that you detect and get alerts on the phone wherever I am. That's right. That's what I mean.
Different connecting devices to the same unit.
Wait a second.
Your own devices. We
were only talking about local network, which is the station within a user's own network. And then he can have access to the data by the UI. And yes, it can be a web phone app, for example. But outside would mean that we have to stream outside, which also implies that people have to somehow make their whatever they have back in network to be accessible from the outside. And most providers do not allow that. I mean, who knows about a DMZ, putting my station into a DMZ, for example. So I see the global view as getting the data from a global service, and that's a totally different story. So I do not see you with your local station in your local network retrieving data from other stations from other local networks.
No, that we won't. We thought of avoiding in the first place, and it's the web GUI is just for monitoring your own station, and it doesn't matter if you use the web GUI on your smartphone, on a tablet, or on a computer in your own network.
Right.
But the possibility to share it one day in the future is there, and we won't deny it. But it's only to think about it. And there is no performance loss.
Yeah, wait a sec. There's a philosophic point that we discussed here. The sharing of your data. First of all, the data that you create on your station is under Creative Commons license and allows us as Ki360 to collect that data and send it over to a central storage. That is not
no, I wasn't talking about that. It is that sharing the view.
Yeah, you can share a view
that's all.
You can share a view from your desktop by any means, like Zoom or any meeting.
Yes, of course. But we're not talking about that at the moment. It is that we have the possibility to do that in a very performant way, but we're not doing it. It's not that we go after that in the first place. It's an option that we in the future may go for.
Yeah.
Because what we design is that it's capable of doing so, even if we won't use it.
Okay, fair enough.
Never.
Fair enough.
Yeah.
We just have to be sure that our stations, the stations of our stationeers are infringible. So anything that's
it's a security issue.
Is for me a black flag, a red flag.
Yes, it's a security issue, and we won't let that happen. Yeah. But we have the possibility to do it in the right way if we want to in, let's say, 10 years.
Yeah.
I don't think that we are going to want that we want to. But
the use case that I'm curious about, and I saw it on my telescope with INDI, that I can actually now actually tell my telescope to listen to jobs that others are interested in. So if they want to track a certain galaxy or whatever, and my telescope can see it, it will actually take the job and start recording and sending the data. I saw that. That's, to me, very interesting when we have, hundreds of thousands, 10,000 units all over, and when one unit detects something, if others' unit can see it, maybe they want to start tracking it also, right?
Then you have to publish that somehow via a server. But I hope you're not going from peer-to-peer, so...
I can tell you, if it will be peer-to-peer, it just will perform better.
Yeah, peer-to-peer is also...
The management has to go via a central server. Otherwise, it's uncontrollable.
No, I don't think so.
Not true. Look.
You can sign your data.
Yes, so blockchain actually is peer-to-peer.
Okay. Yeah.
It's very
and IPFS also.
Yeah.
Yes. Yeah.
Okay. And we are already using such kind of technology with the Las Cambras Observatory, so that we can do observations at the same time from different telescopes. We're using it to get data for calculating the parallax of, let's say, asteroids. This has to be in a very, very tiny frame window and synchronized. So we actually have that kind of technology. And it can be given down to the amateurs that use their own private telescopes for that.
Okay. Yeah.
My question is it one GUI per station? For example, what if a person has 5 stations? Would they use one GUI or 5 GUIs?
It will connect to the IP address of the station.
Yeah.
And then station will serve the static files, index HTML and JavaScript minified version of it with React, and then you solve it.
We need a station selector. Yes, we are right.
Well,
Or you just open up.
No, we don't.
Again, I will propose something different, right? If you have 5 stations, you already have 5 of the UIs, right? So you already have 5 websites to watch. But I will propose to create another package that is like a master controller that will give you another UI, right? With the view of all other stations, like a summary. And if you need, you can take components from the other and just place them and go deeper to one unit if you want to. Okay?
Like some multiplexer for demultiplexer.
Yeah, security camera.
Exactly, yeah, it's something like that. Yeah, but it's another kind of ROS2 package or another backend that will do that. That you need to run.
Okay, that's a future thing, I think.
Yeah.
For now,
next year.
Next year. May I come back to a question that hurts me a bit? The structure of, you call it a structure. I call it a structure, but I hope you get my point, of the Neo4j database. Somehow this protocol, this how to use the database, how to write that data, has to be written down once. Would you agree?
Yeah, I already have some things written. I designed a few entities like the station, the data source, the sensor, and it has the basic data alongside the what is the type of the sensor, when the data source was created, because for example you can have a station right now basic version with all SkyCam, then later on you introduce SDR, and we can also track that in relations of Neo4j. Like when relation between station and another data source was established, we keep the timestamp. And so I already have something like this, and it is all defined in GraphQL schema file, which we use to represent the data and to represent possible query endpoints and possible mutation endpoints.
Can I imagine that like an UML diagram?
It's a graph. It's a graph, and you have relations between the nodes, and these relations have a direction.
Okay. Sorry to interrupt. I have to step out. I think we made pretty much progress today with the ROS stuff, and I think we are going to carry on the discussion in the next week. I know we talk about it and fill in the gaps for the development guide. So have a nice evening all, and thank you.
Yeah.
Bye-bye.
Bye.
So, Rebecca, you wanted to say something?
I was just wondering if Nikola could post the code.
Yeah, I shared it right now. I shared it. So, for example, here is the schema of this Neo and GraphQL that I came up with. Do you guys see anything, actually?
Yeah.
So, for example, here are the mutations. Okay, there are also queries. For example, you can fetch some info. This is from the boilerplate, but for example, you have this and you have this, your current user to fetch. I didn't work much on it, but this is what I have right now. Hey, dog. So, for example, I here have a few endpoints that are mutation because they change the data. This is from the boilerplate, ignore this part, but this is here. You can set up station and you provide some basic info. Here it is, which is the name of station. This because it gives us GPS as an optional unit, some basic credentials to set up. And what I else did, I started working on a mask. You provide mask, there is a input defined. It looks like this, it's a mask. It contains array of mask rows. Each mask row is a type of a boolean and it columns. And right now I'm thinking to, because we'll use square frames, most likely, to perform some checks like... Yeah, go ahead.
I'll be a key, for example, the location, you have floats there, make sure to use like double float.
Yeah. There is a number, it's a 60, yeah, it's a float, it's float. I was thinking it's number, but it's 64 bits either way. And the nice thing with...
But again, the float will have any accuracy, double will not, because it's a floating point.
In JavaScript, you don't have double. You have only float, but on the implementation level, it's a 64-bit number of some sort. Same thing with Python. It's accurate enough. I mean, there is a lot of decimals.
I have the mask completed.
This is just me testing code and testing GraphQL. It doesn't mean that we are going to use this code. I deleted a lot of code in my lifetime, so I also expect this one to be discarded at some point. So don't worry.
If you want to use that, you can take a look at it. It's in the GitHub.
It's for me to experiment, for example, to deploy it on Raspberry Pi, to see what are the obstacles with Docker and with this. And I don't know, it's just for testing, because I gathered hardware. I want to have a reproducible setup. This is why I bought Nano and Raspberry Pi with 8 gigs, just to play around basically. And I assembled this on my vacation just to see it. I don't know.
So where do you guys want me to post
this website about ROS2? There was some website.
Which channel do you want me to post?
Software dev. Or our private, I don't know, for dev.
So I didn't use the Discord yet.
Would it be better for it to be its own channel?
No need, it's too much.
Here's
the example of
Dev Hangout.
Because it's a whole section of software that he's in charge of. Either way.
We're working on that. I'm actually making a list of channels right now. We'll be revising them. So if we want to add it later, we can add it and move it.
Yeah.
But be sure to archive something, not to lose data.
Oh, absolutely.
Okay, so as this is more or less spoken, any other topics around the backbone of our system?
Yes, there was one more thing that I wanted to show.
Okay.
Just a second, I lost the video.
Wait, I will stop sharing.
No, I lost the entire meeting. Weird. Oh, here we go. Okay, if I share screen. So this is more around monitoring, right? So I use Grafana. I don't know if you guys are familiar with it, but this is...
Yeah, I did use to track servers and loads on server.
So this is a great example of how we can expose kind of matrices and KPIs on our units. Everything from business kind of KPIs. For example, this is how long it takes to produce a block on whatever I'm running here. It doesn't really matter. Or to like a hardware API. This is like the CPU or memory usage, right?
And they could also display logs from our aggregated logs from our station.
Yeah, you can use log. There is tons of ways to how to visualize it. Also, Grafana and Prometheus are kind of you can say like this. I mean, this stuff
from the same category.
Yeah. But you get the point. So I'll recommend once we get to the point, like we want to have kind of stats on how everything is running on the Nano, on the Pi, right? We can collect actually the data and have it, shared on a kind of monitoring app for that. Now, what's nice about that also, again, in case of there is a failure or anything, these solutions can connect to your phone, they can connect to whatever and alert you. For example, if the Pi turned off or it died and it doesn't report anything. So we can do that as well in the future.
So what you're saying, this is a library of widgets, front-end widgets?
So Grafana is about visualizing data. It connects usually to Prometheus, which is kind of think about it as a database that collects data points on a kind of time series database in a way, right? It's very good in collecting KPIs.
But it will not be related to anything like raw SDR data or raw frames. It will just report, for example, frequency, how often frames are generated, but it has nothing to do with images.
Yeah.
Okay.
Yeah, you can say, you can create here like how many detection this unit had in the last, day, week, month, year. Show it in a graph if you want. How many airplanes you detected, how many birds, how many UAPs. You can do whatever.
How many UAPs? Awesome.
Yeah, that's what we want, right? That's why we are all here.
So this is not about a web UI widget.
It's a not replacement. It's a not replacement
No,
of
it's
UI.
not replacement.
It's
just debug tool mostly.
Is that something we can build into the support chat? Rebecca, help me. The user interface has a maintenance view. That's it. Does it make sense to put it in the maintenance view?
Yes.
Maybe we can put iframe to wherever Grafana is hosted and have no work to do. Actually, just configure the Grafana.
Yeah.
Okay.
But yeah, we can see it via our GUI through iframe.
Yeah. Mm-hmm.
Okay. Sounds good. So, any other questions around that topic, or did you want to tell us something else, Ido? You started.
No.
Okay.
No.
Okay.
I'm good.
I wanted to jump over to another topic. It's also on the AllSkyCam. It has to do with a tracker. So we are now having, and Wolfgang is here too. He's a developer of, he calls it the compact tracker, which is, please correct me if I'm wrong, basically a canny filter looking for edges and finding blobs that belong together and making a track from that. The good thing is, as far as I've seen it, it is very performance. It's very speedy. And what we were gonna do is compare the simple tracker that we already have in play with a compact tracker and see on the material that we have, the training material, where the benefits of both systems are. So, long story short, Nikola, you mentioned, I think yesterday, that you are working on a simple implementation of loading videos and not going directly from RTSP cams, right?
Yeah, I was talking with Christian and asked him for a task, something that will be required almost certainly. And his idea was to create like a fake web source that will split the MKV files, for example, from simple tracker vids folder, to split them in frames and to serve them in chronological order, to just push them through the web socket and to control the frame rate or something, just not to dump them all at once.
Yeah. Okay, good point. I think Wolfgang, in that
okay,
way,
but yeah,
it would work.
but it.
Yeah.
I think in OpenCV you can also read from video files directly, so I think this would be more.
Yeah, this is what I did. I just basically changed from the camera URL to file path, and then I commented out some things in code.
Yes.
And
I think it was looking quite good. Only the bounding box was not working.
Yeah, this is what I commented out.
So I think maybe you see I did not use parameters or so I
hard-coded the resolution for your camera.
Everything is hard-coded for the
Yeah.
So this was quick and dirty, but I think it's quite self-explaining, most of the stuff. So if you have any questions, you can ask, of course, at any time. But I think it's more or less self-explaining, and so some words about the implementation. So as you might know already, so I did this as I started to play. So I ordered the Fisheye camera some months ago, and then first I used it with the via browser, and okay, you can see the image, but then I wanted to start and do some implementation. So I started to get OpenCV running. Then I checked if I can read the stream, and it worked. And then I was motivated to continue, and so this implementation grow. So it was not even planned. So I started, and then I developed it, and then I got some object. So I was doing this some years ago, maybe 10 or 15 years ago, with normal USB webcams and with PC, and there I used the normal approach. So you make difference frames, so you're subtracting frames, and then you get differences, and you cluster them. So that's the normal way. I think also the Simple Tracker is using this approach. But I thought, it's not optimal. So for example, if the exposure time changes for the camera, so this can happen if clouds are changing, if the brightness of the sky is changing, then you get some steps in image brightness, and then you cannot use the difference frames because everything is different, and so this is a huge disadvantage. And so I thought, well, it would be better to detect edges and objects in the first place without making image difference. And then I discovered then in OpenCV you have this edge detection, which works very well. And then I tried it, and it worked very good. And so I developed this whole thing. And I think then I had to look how do I get rid of the moving clouds. I think the moving clouds are the biggest problem. And so I started to do some filtering on the data. You see, if you look at the implementation, I have the object, so the edge of the object, the length of the edge of the objects, and I'm filtering. I use this as a filter criterion because I'm saying, okay, if the edge has a length more than some threshold, then it's too big. So then it will most likely be a cloud and not an object which we are interested in. Okay, if the mothership will come, which is filling half of the sky, okay, then we will lose. But I think that's not the probability is not very high. So I'm discarding big objects, and this I'm using for filtering. So I think it's working quite well. So I did some weeks, maybe 4 weeks or 6 weeks. I had it running day and night, and I was looking at the videos and what has been detected, and I think I had a very good a very good outcome. So there were very few negative false positives and false negatives. So yeah, but I think you will see if you compare it to Simple Tracker, then we will find out which one performs better.
I already collected several videos where we see Brad even had some.
Yeah, I've got it pulled right now. I'm very impressed by it.
Where we know
I would
that
like
Simple Tracker does not perform good enough. Let's say where for example, objects are flying too fast. Yeah, but Brad, forget about the tree stuff.
Yeah,
we will
so
get the mask
that's
in the
also
future, and there will be no trees. I mean, trees in the distance, yes, but you don't see leaves moving in the distance. But
that's also some feature of my compact tracker. It doesn't need any masking. So of course you could do masking for privacy and whatever, but for functioning it doesn't need masking. So even a moving tree will not trigger any tracks.
Because it's too big. Or what?
Yeah, exactly.
So like the videos I'm doing from say November versus August, the tree grew. So I can, on my past videos, I've got it toned down to 53% mass. Summer videos is 54%.
But you can check it out. If you let it run on your data without masking, you will see that it will be no problem moving tree.
Yeah.
No, but the idea of the masking is also to improve performance, right? If you know there is a tree there and you're not going to get any detection,
Yes.
there is no reason to process that.
True.
Masking is not bad. Yeah, you can gain some performance by masking. That's true.
But still, if you had one large... Sorry, go ahead.
No, I said specifically if you have a 40% on the frame tree.
Yeah, it depends how big you need it.
So what I'm getting on the Nano, so I'm only using the CPU. I don't use any GPU.
Wow.
And I'm getting about worst case it's about 2 frames per second, and normally it's 3 to 4 frames per second for the 12 megapixel stream. I think that's not too bad.
It's not bad at all from what I've tested.
And you expect to move it to the GPU, right?
I don't know how to do it, to be honest. And I also don't know. So I have done some research, and I think the normal image processing functions like edge detection and so on, which I am using, I think they don't profit very much from the GPU. I have not tried it, but what I have read on the net, so the GPU is performing best on the AI stuff, on classification and so on. But I think the normal OpenCV functions, they are even slower in some cases. Some people are writing.
Wolfgang, have you heard about VPI, NVIDIA's new implementation of image and video processing?
No, I don't know it.
Just have a look. Just inform yourself. VPI is from NVIDIA.
VPI.
It's the substitute of OpenCV.
Okay.
And they have examples, and they say it runs like hell.
Okay, I have looked for it.
I don't see a reason that the GPU will be less performance. Maybe if the algorithm
it will rip it apart.
This was for OpenCV. Maybe the implementation was not good.
Yeah, could be.
Richard, and this VPI is for every NVIDIA card, or just for Jetsons?
No, all the Jetsons. Every NVIDIA, every system with an NVIDIA graphics.
So for CUDA.
CUDA support.
Yeah.
Okay.
By the way, they released a CUDA for quantum computing.
For quantum circuits.
So they have qubits now. Yeah.
Did they need it?
So, first of all, they're already using it, right? The reason it's out is because they are using quantum computing, and they are expensive and not really reliable when you speak about more than like, Honestly, I don't know how many qubits they have today. I need to check it out. But I do know that there are some companies that had big advancements, and they are forecasting within 10 to 15 years we will have a quantum CPUs, like a graphics card. So it will be on mobile applications, like even on phones. I don't know how
heavily shielded
and
Yes.
cold.
So you're wearing a 5 kilo watch then.
Yes, it looks like they are solving the cold issues. They already solved it for the superconductors. So superconductors.
Room temperature.
They have some superconductors at room temperature. Yeah, which is insane. Yeah, but the world is gonna change in 10 years.
Yeah.
Drastically.
So we have 8 minutes to the clock. I just wanted to raise a last topic, and it's actually a quick one. Brad, you created almost 300,000 images, cropped versions, or cropped already?
No, not cropped.
Not cropped. Okay, I created almost 300,000 cropped ones. I'm now packaging them.
Awesome.
One package is 150, the other package is 300 megabyte. I put them on WeTransfer and I sent you the link, Nikola.
You did? Oh.
No, I did not send. I will send tomorrow.
Yeah. Thanks.
I still have to pack them, and packing takes time.
Yeah.
For sure. What was the target? I forget. Was 3 million, 4 million?
Let's start with under the 500,000. Let's start with that and see what happens. Because so far I only had the opportunity to work with 10K. Maybe this will be enough. I don't know. Maybe when we have this much images for unsupervised clustering, maybe cluster probability will increase, and we will have a lot more examples that have cluster probability above 90%.
Okay.
Because he got more experience, but I don't know. I can't even guess.
Well, I'm out of ammo, basically. I can only produce images now as I get them in 12-hour batches, basically, for my camera. So my production is going to get real slow here, real quick, like as it already is. I've finished today's batch. So I need to get that cropping tool from you, Richard, and try it out on mine. There's a problem with my security software, and it has to do with the NAS, and it gets hung up. So it records a full image. Well, the file has a full file size, and it has the length, right? But for some reason, I guess it's encoded incorrectly. There's some snag. It'll play part of it, and then you basically skip to the very end of it. So it has broken bits. So you can actually scroll your time slider for the parts that work, but when you get to the parts that are corrupt, you shoot right past them.
In Simple Tracker repository videos folder, are there your videos? Because when I open them with VLC, I see messed up video length. It's like minus 156 hours or something like that. And I can also use the scrub bar, or how is it called? Only like 1/4 of the entire length. And yeah, is that the same thing?
Must be a corrupt file.
Well, it's through this.
But it's still usable, some parts, I guess.
But it's hanging up. So when I run Simple Tracker on it, what I've been doing is I have these huge, like 14 gig folders I'm running it through. If it gets 60% of the images, or it goes through 60% of the videos, fine, whatever. I'm going to make more, so I just keep moving on. I did not notice, though, it wasn't writing the one file, the one subfolder it did for the one video it failed on and stopped the process. It didn't write the JSON files. It didn't annotate it. I know. So I can search and I can get rid of all the other stuff, but I can't do like a negative search and find the missing JSON file in the middle of like 400 folders. So this is the problem I'm going to have when running that thing sequentially, running the crop tool sequentially. Okay. I think it's just something I can do a check on, because it should be. I can account for all of it.
We add something to the cleanup tool that it also cleans up folders where there's no JSON.
Oh, it does?
No, we can't do that.
That would solve.
That would
That would solve the problem.
Yeah.
Because I can see the main folders that are going to be missing a JSON, but I can't. Then I got to go through however many subfolders there are to find that.
No, you can't do
bit.
that.
And there's like, well, I can. It's just going to take a while.
No.
I don't want to do it.
Wow. We do it in the next couple of days, okay?
Okay.
If you are available.
Okay. Well, then I'll generate some more images in that amount of time, and I can add to the pile.
All right. So on that note, any other contribution from anyone? A question or an idea you want to raise? If not, I'll say we wrap it up for today, and I stop recording.
Okay.
Did I? No.